All right, welcome back, Mr. Piels with Calculus. This is Unit 1, Lesson number 8, and we're going to be learning how to find the limits of composite functions, f of g of x or vice versa. All right, so we have a warm-up quickly, which basically you can see yourself. This is what we had done before, so the limit as x approaches infinity of 3 would be 3. This is already split up by the properties, and this here, the top has a smaller degree than the bottom, so therefore it equals 0. And this time the exponents were the same, so they have the same degree, so therefore basically the coefficients are the answer, and then all you had to do was simplify. All right, jumping back into, so this is the rules for finding a limit of a composite function, f of g of x or g of f of x. No matter what the name of the function is, it does not matter. So these are the two main rules. Basically, what we have here, in order for this to be equal to this, in order to find the limit of a composite function, the two things that must be true, well, there is actually some way around that, which I'll get to there, that's where it gets tricky, is that g of x has to have a limit. So the inner function must have a limit. In other words, the left and right hand sides must be approaching the same height of the inner function. So that's the first rule. The second rule is that the outer function has to be continuous at whatever value that is. So whatever that height was where the left and right sides met, well, f would have to be continuous when x equals that same number. All right, so now there is an exception to this, and that's where it gets pretty tricky. But the first question is pretty straightforward. This does exactly what we just talked about. So if we have f of g of x, what we do is we first find, well, does g of x have a limit? So we look over here. We say the limit as x approaches -3, so -3 is right here. Does it have a limit here at g of x at -3? It does, because the left and right hand sides are approaching the same height, which is 3. So essentially, everything in here inside the parentheses is 3. And that's how this turned into this, because it does have a limit right there. The left and right hand sides do meet at the same height. So now we find f of 3, but remember there is that rule that the f function, the outer function, has to be continuous at that value. Well, if I look over at 3 right here, I know I kind of wrote over it, but there's no hole there. That is a continuous piece. So yes, the answer is -1. At 3, it has a height of -1, and it is continuous. So yes, both rules were met in this first example. But this is not always going to happen, and this is when things start getting trickier. So now, in the next example, example number 2, it might not necessarily be true. So the limit as x approaches 0, so f of g of x, now of course they're giving us, so that basically means the f, as the limit as x approaches 0, which is right here, of g of x, which yes, it does look like that it is approaching 0 from both sides, so yes, the limit does exist. But then I ask myself, well, that's a height of 2. Does f of 2, is it continuous? Does it meet that second rule? Well, it doesn't look like it. It looks like it's removable discontinuity. It looks like there's a hole there. So it doesn't meet the rule. But there's an exception. It still might actually have a limit, even though it doesn't follow those two rules. And this is where, and you can see I've already kind of revealed some of the information. What we're going to have to do is we're going to have to take it a step further. We're going to have to do the left and right sides separately and see if the left and right sides both have the same limit. And if they do, then yes, this composite function does have a limit. So here's what we're going to have to do. We can do right or left hand. Yes, on the AP exam, you will have to do this. Now, this is kind of a rare situation to occur, but if it does occur, yes, this is how you're going to have to write limit notation. So limit as x approaches 0 from the right of the composite function. What you would first do is find the limit as x approaches 0 from the right of just g of x, which from the right, it looks like it's approaching a height of 2, okay? But specifically, more specifically, it's approaching from a height, it's approaching that height of 2 from below. Look at the green arrow. That green arrow is pointing up, not down, which means if it's approaching from the bottom, that means you go to the left. And that's the reason why I wrote right over left over here. If it's approaching from the bottom, that means the left side of the function. If it was approaching, had it been pointing down and it had been on top, had this arrow been approaching, or had the function been approaching from the top, then yeah, you would have done the right-hand side on the next piece. So now g of x is 2. So this limit is 2, and it's approaching from below, which means that we use the left-hand side of the composite function. So f of g of x, now we know it's 2. So that's g of x, as g of x happens to be approaching 2 from the left. All right, so 2 from the left side, which means it looks like it's approaching from above. It says below there. Okay, I paused it because I was looking at the green. It's red. It's right there in front of me. Approaching 2 from above. It's approaching from above. So as you can see right here in this piece, this is what I'm talking about. This piece is approaching 2 from above. So it's approaching 2 from above, and it's approaching a height of 0. I guess it really doesn't matter. It is 0. 0 at that point. Now, as you can clearly see, the answer is already there. Let's do the same thing on the left-hand side. So we start over here. 0 from the left is approaching from above, and it's approaching a height of 2. So once again, we got 2 again, and that doesn't prove anything yet. So if we go from 2 from above, that would be the right-hand side. Is the right-hand side also approaching 0? It is. So this is that rare case, but even though it didn't meet the criteria for the rules, it does have a limit. The limit does exist. This is not a DNE example. Now, let's look at example number 3. Now, I'm just going to kind of reveal everything first. So let's go through it all from the start. So from the very beginning, the first thing you should always check is, does it work out the way it is? So the limit as x approaches 2 of g of x. So I go to g of x, I look at 2, I ask myself, does the limit exist? No, it does not. It is clearly a jump discontinuity. Okay, so it doesn't exist, so therefore I stop and I check both the left and the right-hand sides. I mean, I know that's a little bit unfortunate. We get a little bit more work, but yes, it could still have a limit, even though we already see the answer is DNE. So let's check it out. So 2 from the right. Here's 2 from the right. 2 from the right is approaching a height of 0, and it's approaching from above, which means 0 from the right-hand side. From above means right-hand side. 0 from the right-hand side is approaching a height of 3. All right, there's 0 from the right-hand side. 3. Now let's do the same thing from the left-hand side. So I go to 2 from the left. Here's 2 from the left is approaching a height of -2 from above. -2 from above. -2 from above means -2 from the right. I go over here. -2 from the right. Well, I guess it didn't matter. It was left and right both approach the same height of +2. So are these two the same? Did the left and right hand sides end up being the same? They did not. That's the reason why this is DNE, because they were not the same. All right, one more example. So I'm not going to show all the notes again this time. So let's do it from the start. First thing I'm always going to do is see if it works out the easy way. Plug -1 in for h of x. Does it have a limit at -1? No, it does not. This is not approaching the same height left and right. All right, so no limit. Easy way didn't work out. Now let's talk about the hard way. So I go to -1. I start from the left. I'll do left-hand side first. It's approaching a height of -3 from above. Remember, -3 from above means -3 on the right-hand side. -3 on the right-hand side is approaching a height of 3. So we now know the left-hand side should be 3, and it is. Now let's do, okay, that's actually the right-hand side. I did left-hand side, didn't I? All right, so now I think this is going to be 3. Yeah. All right, so now let's do the right-hand side. This is the one I actually haven't done. Right-hand side is approaching -1 from above, and it's reaching a height of -2. -2 from the right. -2 from the right. Oh, it's the same thing again. So it's -2 from the right. This one was -3. Oh, maybe I did do the same one. Sorry. Let's do from the left-hand side now. So this is approaching -3 from above. So -3 from above, -3 from above is also reaching a height of 3. Okay, so maybe I did do the right ones. So this piece is approaching a height of 3. This piece is also approaching a height of 3. So yes, the left and right-hand sides are the same. So yes, this composite function does actually have a limit, despite the fact that it did not meet the criteria that we said from the beginning. All right, couple more examples. Now I'm going to do this one without the notes already posted on the page. First thing I'm going to do is jump through it like the normal way. Put -3 in for f of x. See if it does have a limit at f of x. And g has to be continuous. So f of x, where is f of x? That's this one. At -3, it is not. Okay, so clearly no limit at -3. So the easy way didn't work out. So now I do the left-hand side first. So left-hand side of -3 would be reaching -infinity. Okay, so -infinity from above. So I'm reaching -infinity from the right-hand side, which would be the only way to reach it, to be honest. So this piece is reaching negative infinity. It looks like it's going down towards negative infinity. All right, so the answer for the first piece, and yeah, I know I'm not showing the work because I'm worried about my time, is negative infinity. Now I'm going to do the same thing for the right-hand side. The right-hand side is approaching positive infinity from below. So that would be positive infinity. That would be this side, assuming that this is never ending. From below means the left-hand side. Well, that's the only way we can look at that end behavior, to be honest. And that is also going towards negative infinity. So yes, after looking at this question, it does look like the answer is negative infinity. The limit does exist, despite the fact that it did not meet the criteria that I wrote on the first page. So yes, that can happen. So let me go back to it just a quick second. This is the important part. So typically on the easy way, what you're looking for is, does the inner function have a limit? And does the outer function, is it continuous? If that occurs, well, then you just have your answer right away. If not, you'll have to check both the left and the right-hand side separately and see if they also end up just happening to be the same. It is possible that they could happen to be the same thing on the left and the right. All right, thanks again for watching. I know this is a pretty tough concept, so please ask me questions if you have any. Otherwise, I'll see you in the next video. Have a wonderful day.